Yeah.
Hello everyone.
Hello everyone!
Welcome everyone on our video. So in this video, our group are going to explain you about an interplanetary mission of a satellite that we have chosen, and it is a satellite that are going to be trajected to Mars. But first, let us introduce ourselves. My name is Rebecca 136166029.
My name is Rizki 136161116.
My name is Rifaa Afia 136163031.
My name is Faruq 136160026.
Hello, my name is Indrawan 1361613.
MAVEN stands for Mars Atmosphere and Volatile Evolution Mission. This space probe that is developed by NASA to study the Martian atmosphere while orbiting Mars.
It is launched on November 2013 at Cape Canaveral in the US with the mission to determine the atmosphere and water condition on planet Mars. In this video, we are going to focus on the trajectory that direct the MAVEN satellite from the launching site to the final elliptical orbit in Mars.
In the first phase, the MAVEN is in its parking orbit trajectory around the Earth. From the current orbital trajectory, the satellite is wanted to go into the hyperbolic orbit and is needed to be given an additional velocity through a thruster. So, we begin the calculation of the escape velocity. The relative velocity of the satellite to the Earth can be obtained by calculating the difference between the relative velocity of the satellite with respect to the Sun and the relative velocity of the Earth with respect to the Sun. Once the satellite's escape velocity from the Earth's orbit is obtained, other parameters data is needed, such as semi-major axis and the eccentricity of the hyperbolic orbit trajectory. From there, we can calculate the additional velocity needed by subtracting the satellite's velocity at the pericenter of the hyperbolic orbit with the satellite's velocity at the pericenter of the Earth's parking orbit that happens to be an elliptical trajectory. Delta V1 that is obtained from the calculation is 3.58904 km per second.
Once the MAVEN has escaped from the Earth orbit, then the satellite will go through an elliptical orbit moving from the Earth to the Mars. After waiting for some period of time, the satellite will be entering the Mars orbit, and then the escape velocity can be calculated. Moreover, the second escape velocity is obtained by calculating the difference between the satellite's velocity with respect to the Sun and the velocity of the Mars with respect to the Sun.
When the hyperbolic orbital parameters are obtained, then the declaration needed in order to find the difference between the satellite's velocity at the pericenter of the hyperbolic orbit and the velocity at the pericenter of the satellite's parking orbit. So, based on our calculation, MAVEN's velocity when entering Mars is 2.65 km per second. And then, we get the hyperbolic orbit parameter when entering the Mars based on this equation, and the final result is we get minus 698.6828. This minus shows us that the orbit is hyperbolic, and then for the eccentricity, based on this equation, we get 1.5525, and MAVEN's angle when entering the Mars orbit is 130.0999 degree.
From the given delta V1, we can compute the propellant mass required to escape from the Earth's elliptical orbit to the hyperbolical orbit trajectory by using the Tsiolkovsky equation. And by that equation, we have the result is about 2,451 kilograms of propellant mass needed. The period can be calculated, and thus the time needed for the satellite to enter the Mars can be computed as well. And by the equation, we know that it takes about 8.62 months, or about 8 months and 18 days to enter the Mars trajectory. And the change in speed required for the satellite to transfer from the hyperbolical trajectory orbit entering the Mars elliptical orbit is shown in the following. The mass of the propellant needed to transfer orbit is about 2,443 kilograms.
Okay, so based on our calculation, we need an additional velocity around 3.58 kilometers per second in order to escape the Earth's gravity. Once we have that velocity, and then we need to wait up until 8.6 months, or equals to 258 days, in order to enter the Mars sphere of influence, or so-called as SOI.